Yeah, comes on everyone. Let's start off. So last thing, this is what we're doing. Infinite branch. Okay, next thing. Hmm. This is A and this is B. All capacitors are identical. Let's get this thing. Find CAB. Hmm. Now, listen carefully. So when you solve the circuits, right, there is something called, there are two types of symmetries here. Not in this exactly. So listen carefully. We'll get back to this question. The first thing, perpendicular bisector symmetry. The name I gave, you can call it whatever you want. So what the symmetry says is, if the two terminals of the battery A and B are on either side of a symmetrical line, meaning the left side and the right side are mirror image of each. Now see, they can be like this also. A and B can be like this also, line can be like this also. So the main thing is A and B should be either side on the line. So here A and B are terminals. First thing, Since the left side and the right side are exactly identical, all the points in the middle will be the midpoints. The bisector would be equipotential. That is, all nodes on that line have same potential. Therefore, any element between them can be removed. So if you kept a capacitor between those two, meaning, for example, you kept a capacitor like this, you can remove that. The second thing, the nodes along the symmetrical line can be opened up. Along the line. Now, what do you mean by this? Let me show you with this, the previous example only. So in the previous thing which I gave you here, so this is A, this is B. If you look at this is a bisector symmetry. The left and the right are exactly mirror images. The meaning of this is, now look at the symmetry. Let's say charge Q flows here, charge Q comes out. If you say charge Q1 is flowing here, by symmetry, Q1 should flow here. If you say this is charge Q2, by symmetry, this should be charge Q2. Isn't it? Whatever happens on the left, the same thing will happen on the right side, but instead of flowing, it will be going away towards the negative terminal. Now you tell me, this node which I have, by removing this node, does that affect the charge flow? If I just open that up like this, you'll observe this flow, which is Q1, this is still Q1, this is Q2, this is still Q2. Did the charge flow get affected in any way? No. So you can open up this node. This is what is the second point means. So on that line, if you have any nodes which are there, you can just open them up along the same line. Is that making sense? That is because whatever charge flow happens on the left, the same symmetry happens on the right. So even if that node is there or not there, the circuit won't understand if there's any difference. So removing the node will not affect anything in the circuit. Is this making sense? So now using this logic, so if I remove that node in the middle, now it actually becomes easy to solve. Now it simply becomes series and parallel. So the CAB, how much is this? C by 3, C by 2, 5, C by 6. That is the reason you can remove that node in the middle. This is perpendicular bisector symmetry. Now, other than this, there is one more type of symmetry called axial symmetry. Let me give you an example in this. If I give you one more example, think of like this. Let's say I have a circuit like this. Let's say each branch is a capacitor. Now you can clearly see here, this is a perpendicular bisector symmetry. The left and right are identical. So what you can do here, and then draw them exactly in the center, but you got the point. This will become like this. You're getting how I open the nodes? You can remove all those nodes in the middle. You can just open them up along the line of symmetry. That is the meaning of opening the nodes. As long as the left and right or the A and B are identical about this line, I can just open up all those nodes in the middle. The circuit becomes a little simplified. Is this example making sense, everyone? So this I call it perpendicular bisector symmetry. If there's any official name, that's a different thing. So it is important you name them so that when you solve circuits, it will be easy for you to figure out, okay, this is that symmetry, this is this symmetry. Now there's one more symmetry, axial symmetry. So in axial symmetry, we have A and B. The equipotential, the symmetrical line is passing through A and B. Node wala point. This thing.
Yes, sir.
Now this thing, right? The symmetrical line passes through A and B, meaning up and down now are symmetrical. So how do you know whether it's an axial symmetry or bisector symmetry? In bisector symmetry, the line, the A and B are on either side of the line. In axial symmetry, the line is on the points A and B. So in this case, what happens? Since the up and down are exactly similar, are identical, so therefore can be overlapped in parallel. You can fold the circuit, meaning now you can clearly see here, this is A and this is B. The up and bottom are identical. So you can clearly notice here, look at this thing. This point here, if I call C, this point is also C. If I call this point as D, then this point is also D. Do you agree? Now, if I fold the circuit, meaning this is what you're doing. You're folding this capacitor with this capacitor. You're folding this capacitor with this capacitor. You're folding this guy with this guy. You're folding, the value is bad. This guy with this guy. this one with this one, this one with this one. Now, when I fold it, so what you're literally doing is you're putting this point and this point in parallel to each other, isn't it? So if you keep two capacitors in parallel, then what happens? The capacitance will become double, keeping it in parallel. So when you fold the circuit, this is what it looks like. This is what would happen. This guy will remain C, this guy will remain C, because see, you're not folding this guy with anyone. That's a single capacitor. But everyone else will become 2C, 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 and 2C. Whichever capacitor, fell on itself, like, when you fold them, the two capacitors will give you 2C equivalent. And the middle capacitors, right? There is only single capacitor. There is no other capacitor which is falling on itself. So there's only single one. So these two guys in the middle will remain C. Everyone else will become double. Why will they be equipotential? God, batteries between A and B. क्या बात कर रहे हो? A and B are terminals. Battery is like this. Is this making sense? This is your axial symmetry. So now you can use this. You can have both the symmetries. Now, because there is a perpendicular symmetry, you can remove the node also. If you have 10 symmetries, you can use all of them. The best way to use this is let's solve a problem. Hmm. Let's get this thing. Each segment is a capacitor. This is a capacitor. Here, have a look at this thing. Axial symmetry. Hmm. Try. This is a 3 into 3 grid I gave. यहाँ पे example में this was a 4 into 4 grid. Let's do 3 into 3. 4 into 4 you can try. That's a little more complex. 7 by 13. Anyone else got this? Hmm, 7 by 13. Okay, we have two 7 by 13s. So there are two symmetries here. This is there. This is your axial symmetry, and this is also there, which is a perpendicular symmetry. So first, if I use axial symmetry, this is how the circuit would look. Everything will become double. Then you fold them, na, so everything becomes 2C. So every one capacitor overlapped on the other. And then you can also remove the thing in the center. There. Making sense? Both will work at the same time. Now, if you look at the upper branch here, that is 2C and 2C, that becomes C. C and C, that is again 2C. So the total upper branch would be this would be 2C, 2C, and this branch would be 2C again, and this branch would be 2C again. This branch in the middle will be C, 2C, 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 and 2C, that is 2C by 4. That would be C by 2. This is how the circuit would look. You can simplify this further. Now it is how much? This guy is 2C by 3, 2C by 3, C by 2. 4 by 2 by 3 plus half. 2 to 4 plus 3, 7. 7 by 6. 7 by 6 into C, 13 C by 6. What did I mess up somewhere? You guys got 7 by 13? I did mess up somewhere, I guess. That is 2C by 3. 7 by 6. Where did I mess up? So far, right? And you
हाँ
4
सर I got the same.
same ना? Then ये कितना हो गया? 2C by 3 था ये? 2C by 3, C by 2 are in parallel. Did I miss any one capacitor? ये सब ठीक लग रहा है.
सर ठीक है ना आपका वही आना चाहिए. It should be 70 by 13 only.
I'm doing something else weird. Last step में 7, 6 by 7 plus 1. Yeah, 13C by 7 ना?
Yes sir.
You all wrote
70
7C
by
by 13
13.
then?
70 by 13 ही होगा ना. You got 2C, 7C by 6 and 2C in series. So
ठीक है, ये लिख
you
लेते
have
हैं ना.
2C plus 6 by 7C by 2C.
ठीक है. I'm just adding up something else, I guess. ये कितना आता है ये? 2CC, 2C by 3. ये 7C by 6 ना?
Yes sir.
Then they're in parallel, right? तो 7 series में तो 7C by 6 into C. Yeah. 7C by 13 आ रहा है ना?
Yes sir.
So you guys all typed 13 by 7, I guess. No, right only.
7 में 31 की.
Yes, I'm testing all of you. Clear this. This is what happens. You did such a big thing and you're messing up the additions. Clear this. अच्छा, you got glasses और वो ऐसा कुछ इधर Zoom का कुछ फीचर है?
अरे नहीं सर, it's like
You have glasses. चलेगा. You have eye infection. We'll think like that. इसका क्या करना है? ये solve करोगे 4 into 4?
Then when we tried solving 4 into 4 in class, I think sir said it won't work or something.
इतना easily नहीं आएगा. You have to again use nodal analysis.
अच्छा.
ना वो बीच में ना अटक जाओगे सर्किट पे. You won't get that. So give it a try and see. That you have to use nodal analysis. Is this clear how to use the symmetry? Let's see one more. Let's say you have a star like this. Black magic star. So again, each segment is a capacitor. This is A, this is B. Find CAB. If you don't like this star, we can have another star. This is A and this is B. You can also have this is X and this is Y. So find CAB, find CXY. Each segment is capacitance C. Let's get the stars. Six C by 7, 3 C by 10. Okay. Let's see the first one. Now see, this is A. If you drop a line here, this is B. So left and right are identical. That means this point is C. This point is also C. Right? That point can be removed. And top of it, if you look at this branch here, this is C, this is C, and this is C. This is C and C is C by 2, C by 2 and C. So this whole branch here is 3C by 2. Similarly, this whole branch here is 3C by 2. This whole branch is 3C by 2, this whole branch is C by 2. This circuit simply becomes like capacitor, and then we have 3C by 2 ka branch, and the guy in the middle is removed. There's one more 3C by 2. Then you reach B. This side also will be C, 3C by 2. And this capacitor in the middle, right? This can be removed. Make sense? Because this point and this point have same potential, that capacitor can be removed. This was point C and this was point C. You could have folded it also, but it is the same thing. So the left side will be how much now? 3C by 2, 3C by 2, 3C by 4. 3 by 7, 6C by 7.
Yes, sir.
Is this making sense, everyone? The thing in the middle can be removed. Get the second one, star. Two questions are there. CAB, CXY. Means if you keep the battery between the up and bottom, what is the capacitance? If you keep the battery between these two, then what is the capacitance? 3C by 5, okay. Try. I'll give 2 minutes. So when you take between A and B, you can clearly see the left side, right? This point have same potential. This point and this point have same potential. You can remove those two in the middle. And this branch here would be again 3C by 2. This is also 3C by 2. 3C by 2. 3C by 2. So we have one capacitor. So C, 3C by 2. This is how it looks. This entire triangle here will become 3C by 2. How much is this? Three C by 5. Clear? Any doubts on this? Please ask me. You can remove these two in the middle. this capacitor and this capacitor, they can be removed because the potential is same. Actually, now when you fold them, you'll clearly see, when you fold them, you know what you will see? The capacitor will be like this, hanging in air. There is no terminal on the right hand side. That means no charge will go through that. So you can remove this middle ones. What about the other star? The second star, I think, little messed up. It's little more complex in calculations. It is easy only, but this is X and this is Y. If you see here, this is a line of symmetry. You can open up all the nodes. This is 3C by 2, 3C by 2, 3C by 2, 3C by 2. That much we can do. This is X, this is Y. And this node you can open up in the middle. That would be just two parallel capacitors actually. Isn't this how it looks? नहीं, एक और कैपेसिटर है बीच में. Yeah, here it is. Make sense? There is a capacitor here also, no? So there is one branch vertical. There are two vertical branches, and दोनों का branches बीच में there is two capacitors here, and then you have those four triangles of 3C by 2. And now it is easy. How much is this? 3C by 8. 3C by 8, and this is 3 by 14. 3 by 14. Numbers are really bad. C by 2. I can add it up, no? क्यों कर रहा हूँ ऐसा? 3C by 8 plus half, that is 7C by 8. This whole thing is 7C by 8. That and C by 2. Seven by 22. Nine by 11. Yeah. 9C by 11 आ रहा है. Check it out. It's just a matter of series parallel. You have to be careful with the calculations. Clear? I hope everyone is getting the symmetries now. So these are actual in this thing.
22C by 7 उसके बाद क्या किया?
ये दोनों भी ऐड करना पड़ेगा ना रे, प्लस हाफ.
हाँ, so we can add C by 2 ना, तो 22C by 7 plus c by 2. How will it be 9c by 11?
I don't know. My max is weak. Check kar lena. You guys know series parallel. Next thing. Let's not waste time on addition and subtractions. We all are grown-ups. We trust each other, especially in additions and subtractions and multiplications and divisions. So you can try that. Circuit to clear hai na? Ho gaya. Physics is done. Next thing. Today anyway, I'm goofing up a lot of calculations. पता नहीं कुछ का तो सेम आया, so we must be right. If you want to fight, fight with Kush. Next one. The circuit is going to infinity like this. The circuit is going off to infinity. It's an infinite grid. They all go to infinity like this. So circuit is becoming smaller and smaller and smaller. Let's get this. What are the catch? If you see there is a actual symmetry, bisector symmetry. Now see the thing is, before I know some of you without thinking you must have done, you need to understand this whole thing and this thing are not same. Because if you look at here, this is A and B. Look at this point here. This is hanging in air, but look at this point. This is touching the terminals. So first you need to remove the node. That is the main idea. You should say by bisector symmetry, all nodes can be removed on this and you can remove all these nodes. Now you can say if the whole thing is X, this inside thing is also X. And then you know what to do. Let me show you that. You can remove this node here. You can remove this node here. split this node, this node. Basically, you can remove all those nodes now. Now they look symmetrical. Arey God, they're not same potential. God, this is a bisector symmetry. Left and right are not same. वो actual symmetry है. उसमें क्या होना चाहिए? You're getting it. Battery should have been. Yeah.
That's a big mistake.
Meaning, whenever you think like that, ना ऐसा सोचो. If you say this and this are same, you're saying A and B are same. And you're connecting between A and B. That's the best way to remember if you're getting confused. Now let's see A, B equal to X. That means this whole branch, I can write it as you can replace the entire mid in the infinity with an X. Now this C equivalent is equal to again X. Got it? You get a quadratic or something like that, you can solve. How much is that? This is C by 2. That is C by 2 plus X. C by 2 plus X and C by 2. C plus X plus C by 2. Solve this, you'll get an answer. Root 3C by 2. Okay, I don't know. Check out your answer. This is an infinite grid with a actual symmetry, bisector symmetry. Clear with this? We say X is lying on the bisector. But कुछ फायदा नहीं है ना. X is lying on the bisector, so what will happen? See, when you say like this on the bisector, meaning this potential, this potential, this potential, this potential, this potential is same. If you had connected a capacitor like this, you could have removed that. Make sense? You could have removed that one. So left and right, you can't do anything. You can only remove nodes in this symmetry. Next one. This is an infinite grid. All segments are capacitance C. Meaning each one is a capacitor. You got the point. So choose any points here, A, and choose this point here, B. Means you're connecting the battery between A and B. Find CAB. Think for a minute, then I'll show you there's a way to do these kind of questions. Let's see. Now listen, we use something called principle of superposition. So this is what we do. First, assume there's only one battery. So let's say assume only charge Q, assume only A exists. And let charge Q enter A. And you took this point A here. And let's say when you send charge Q here, you can see by symmetry, it will be Q by 4, Q by 4, Q by 4, and Q by 4. Basically, the charge is flowing till infinity. So the charge enters at A and leaves to infinity. Now, similarly, assume only B exists and charge Q is coming out of B. Now, so you need to understand one thing. The charge distribution rate doesn't care whether you send through A, B, and then you add them, or you do A and B at the same time or anything. So B will think the charge is coming outside Q. So Q by 4, Q by 4, Q by 4, and Q by 4. So the main idea is this. Whenever you take charge from here, so A was looking here, B would be here. Now, if you do both at the same time, this plus this, you took A here, you took B here, and if you connected a battery between them, voltage V, and let's say now charge Q is flowing like this. Now, whenever charge A enters Q in this branch, you will get Q by 4. Now, whenever charge Q comes out of B, the same branch, you'll get extra charge Q by 4. Agreed? Both of them will happen at the same time. Whenever charge A enters only A, you get Q by 4. Whenever charge comes out of B, you get Q by 4. If you do both at the same time, you'll get Q by 4, Q by 4. That means the capacitor in the middle branch between A and B has a charge of Q by 2. The capacitance is C.
Sir,
So
how
potential
Q by 2?
difference Q by 4 plus Q by 4
So why would you
of
add them?
1. Okay, what will you do then?
So it is the same charge flowing now, Q by 4 channel.
Who said it is the same charge?
It is not the same
So
charge.
you mean to say this Q from will go here and jump into this problem and come out from here?
So branch में if we see we have only Q by
No,
4
I
charge.
don't care about all that. See,
Both the
who said
conditions.
Q by 4 when? Q by 4 when? Q by 4 when?
अच्छा.
If
Okay.
your mom beats you 2 times, let's say you in the house, you broke the TV. Your mom beats 2 times, right? Your dad comes to beat. Then you say, no, dad, you can't beat because mom has already beaten 2 times. It doesn't work. Mom beats 2 times, dad will beat 3 times, 2 plus 2. When both of them beat together, you get 4.
Okay, sir, got it. I'll
You
be
still
careful
have
next
doubt,
time
you
with the
can
bank.
try breaking the TV today and see. Yeah. So it's like this. अब तो सोचो ना, there's a TV in the house, you're there alone. Alone मतलब only mom is there. You broke the TV. Mom beats you 2 times. Dad is only there, you're there, you broke the TV. You get 2 times. When mom and dad both are there, actually it will be 2 plus 2, 22 times, but ठीक है. But you got the point. Principle of superposition. So what is this thing? This is nothing but the potential difference V. Q by 2C. So this is Q by V, which is C equivalent is nothing but 2C. There, that's your answer. So CAV is 2C. Happens, it happens. Is this clear, everyone? You're getting my Ishan. What you're doing when only A was there, you would have got Q by 4. Only B was there, you would have got Q by 4. Both are acting together at the same time. Each one will try to push each of their Q by 4s. So the net flow in that would be Q by 2. You can't say the same Q by 4 had come because of this guy. No. This Q by 4 came because you're entering charge from this side. The reason why you got charge in that branch, for example, see, if I had said like this, if this was Q1 and if this was Q2, would you still said it will be Q1 by 4 here?
No. So
Won't you say Q2 by 4 now?
Mhm.
Then problem nahi aata tha. And in the end, I'll say Q1 is equal to Q2. So it would have been Q by 2. Because you saw both that Q and Q, you felt that way. But if I had sent Q1 and Q2 here, the charge in the middle branch would have been Q1 by 4 plus Q2 by 4. That would have made sense. And in the end, I will say Q1 is equal to Q2.
Sir, what is wrong with, assuming axial symmetry across AB ऐसे तो सारे vertical जो
नहीं,
capacitors
see, this is the symmetry, ना?
हाँ
तो कुछ नहीं, you can just fold them, right? ऐसे fold हो जाएगा उसमें, तो ऊपर का branch चला जाएगा. And all the bottom ones will become double, right? 2C.
right.
Then what will you do?
No, but एक second.
And then there is one more symmetry like this, ये symmetry बोल रहे हो, left and right.
Yeah.
In that you can remove all these capacitors.
हाँ.
बस कुछ नहीं कर सकते उसके बाद. You can fold once and you can remove everything between these capacitors, but you can't do anything other than that. Simplify नहीं होगा अभी भी, because this branch is still infinity, ना? You still have infinity sitting there. But all got the idea of this thing, the grid. Let me show you a variation of this now. You guys try. Infinite benzenes. We can call it honeycomb bits, still hexagons. You got the idea. This is A. This is B. Let's find that. Infinite honeycomb. Again, same logic, each segment is C. I could have taken this point also. This is still easy. If I take that CAC, that is still easy. AB would take care of that. Try. नहीं रे कुछ. You found that adjacent branches you found.
हाँ तो एडजेसेंट का निकाल दिया. आई डिड नोटिस कि भी उस साइड पे है.
Aryan, I don't think it is 3C रे Aryan. वो adjacent वाला easy है. And B easy है, इतना not difficult नहीं. Just try to see something. Idea is the same. You send charge through A, you send charge through, take out charge from B, and then you do the symmetry. When you get infinite grids, this is the way to do. There is no other way that I could figure out till now. 3C by 4, I don't think so. Just give it a try. Yeah. Oh, some, let's see. See. So let's say only charge Q is going through here. Then you can see by symmetry, each branch will take Q by 3, Q by 3. And again by C, if you see it splits here, it will be Q by 6 and Q by 6. The same thing when you do here, the charge Q coming out, this would be Q by 3, Q by 3. This branch would be Q by 6, Q by 6. Means if I do both at the same time, you will notice from A to B. So when you're sending this charge Q here, this guy is sending Q by 3 and this guy is sending Q by 6. And when I send Q from here, this guy is sending Q by 3 and this guy is sending Q by 6. Make sense? And let's call this point C in the middle. So VA minus VC will be Q by 2C. VC minus VB is also Q by 2C. If I add them, I'll get VA minus VB, that is where you connected the battery, is Q by C. So charge by potential difference is nothing but C, which is nothing but C equivalent. Answer is C. Such a big infinite honeycomb and you got C. Check it out. Got it? So first branch it will go to Q by 3, then it will split into Q by 6. So when you're sending the charge, right, from A to C, the red one will go Q by 3, C to B, red will go Q by 6. But the green one will go C to B make Q by 3 and A to C make Q by 6. So net in each one, only Q by 2 is flowing. Meaning this is how it would have looked. Capacitors, if I draw now, this is A, this is C, and this is B. This would have been Q by 2 minus Q by 2. This would have been Q by 2 and minus Q by 2. That is how the charge distribution would look between these two branches. Is this clear, everyone? These are infinite grids. Clear? Next one. So there, whenever they give you circuits, right? This is one way to do. There's one more thing called diagonal symmetry that we will say. It is really not that of a great thing. We have to use that in conjunction with Kirchhoff's law. So whenever they give you circuits, right, first thing check if there is anything series parallel. Then check for Wheatstone bridges. Then check for if there are any points which have common potential. If you can find, the biggest idea is this. If you see a conducting wire just going from one point to another, there's a high chance it's a nodal analysis. You make the nodes, same and redraw the circuit. Most of them will get simplified. Fourth is symmetries. Symmetries when you saw cube ka symmetry, you saw infinite branches ka symmetry, you saw infinite grids, and then you saw axial symmetry, you saw bisector symmetry. So symmetries mein there are variations. Right? The next thing, the last one is a Kirchhoff's law. There is also something called, star delta and all. Will not do that. That's nonsense. That when you are in electrical engineering, right, you can do it in second year. They'll teach you if you take electrical. But you can solve most of the circuits with this. So first, let's see the Kirchhoff's junction law. Now, Kirchhoff's, right, there's a junction law and loop law. Both have their own advantages. Junction law is pretty useful if you're just solving, only capacitors and only resistors. Loop law is pretty useful when you have capacitor, resistors, different elements mixed up. So let's see each one. So Kirchhoff's junction law, what it simply says is the charge entering a node is equal to charge leaving the node. Conservation of charge, basically. So that means if someone says there's a charge Q1 entering here, Q2 entering here, Q3 is also entering here, we can be sure Q1 plus Q2 plus Q3 is 0. The net charge is 0. So what we do in this thing, if you have multiple capacitors, let's say C1, C2, and C3. Let's call this point X. Let's call this point V1. Let's call this point V2. Let's call this point V3. So this is how we do. Let this charge be Q1. Let this charge be Q3. Let this charge be Q2. So from junction law, we know Q1 plus Q2 plus Q3 should be 0. But what is the charge? Charge is nothing but capacitance C1 into potential difference, which is X minus V1. What is Q2? Capacitance. Q is CV, right? We are using the formula Q is equal to CV. C2 into potential is X minus V2. Q3 would be C3 into X minus V3 equal to 0. Solve, you get X ka value and you're done. This is the primary way to do it. Clear? Let's see a circuit. Example, let me give you an example to solve. Let's say this is V, this is 2V, this is C, this is C, and this is 2C. Now I want to find the charge on the capacitances. Now the biggest hint that you have to use Kirchhoff's law is when you see two batteries. The moment you have two batteries, now look at this thing. So whenever you see a circuit, think like this thing. Is there anything in series and parallel? Nothing. Anything in Wheatstone? Nothing. Nodal analysis, no. Symmetry, no. Gone. Matlab all four cases are 1. Then you come to the fifth one. Then you have to use nodal analysis. So this is how we do. Step 1. Choose a point with 0 potential. Now see, the circuit doesn't care about the potential. It's always interested in potential difference. So you can start with 0. Choose a point with 0 potential. So I will choose this thing as I'll start with this thing as 0, 0, 0. Step 2. Find the potential of other nodes and name the unknown nodes. Some of them you can find, some of them you can't find. So you just name them with a symbol. So in this scenario, if this is 0, the battery will make this 2V. If this is 0, this will be some X. If this is 0, this will be some V. This much I know. Isn't that what a battery does? Step 3, apply junction law. Now, I will assume this guy is Q1, this guy is Q2, this guy is Q3. That is just for the name of the symbols. It really doesn't matter. So Q1 plus Q2 plus Q3 is 0 because no charge can leave the things. What is Q1? Capacitance into potential difference. So we are always taking from initial to final. So capacitance C, what is the potential difference? You're going from X to V. So the potential difference is X minus V. What is Q2? Potential into X minus 0. What is Q3? Capacitance into X minus 2V equal to 0. C goes off everywhere. You end up with X minus V plus X plus 2X minus 4V equal to 0. This will give you X is equal to 5V by 4. Make sense? Okay, na? What do you want to find? Charges there? You know all these charges Q1, Q2, Q3. Substitute, you will get the answer. Do you want to find the charge Q1? So Q1 was C into X minus V, which is CV by 4. Q2 was C into X, so 5 CV by 4. Q3 is X minus 2V, that is minus 3 CV by 4 minus 3 CV by 2. Meaning, I thought Q3 is going to the right, but in reality, Q3 is coming to the left. Make sense? So in this case, these are the positive plates. Meaning, if I write the final charges now, this plate is plus 3 CV by 2. This plate was minus 3 CV by 2. This plate is CV by 4. This plate, I'll just write the positive plates now, 5 CV by 4. Those are the final charge distributions. Is this method clear, everyone? This is the junction law. This is how we use this. So step 1, start with a 0. Find the potentials. If you can't find something, make them X, Y, Z, jo bhi hai. Step 3, in every node, assume Q1, Q2, Q3, find the charge, net charge is 0 and done. You'll get the values. Is this making sense? I'll give you one now. You guys try. Any doubts on this page? Others, do keep your cams on. We have a battery, we have a capacitance, we have a battery, we have a capacitance, we have a battery, we have a capacitance. V, 2V, 3V, C, 2C, 3C. Find charge on the capacitors. Now, in these kind of circuits, equivalent capacitance doesn't make sense. Let's get this. So if you see multiple batteries, mostly it's nodal analysis. Like I said, whatever techniques I'm teaching you, literally the same techniques we use in current. At least the circuits part, it is almost the same, but current may we have other stuff. So mm, 3B, 3C रहे वो. I wrote 3C. But उससे charge कैसा आएगा? God, what will it do with the equivalent?
फिर equivalent और R equivalent निकाल के Q is equal
R
to C.
equivalent कहाँ पे?
C equivalent, sorry, C equivalent.
Then that will
तो
give
Q
you charge
equals
on
C
what?
है.
That will give you charge on what?
Oh, वो तो net charge आएगा. Okay, sorry.
Again, same story there. Step 1, find the point. Choose a point with a zero potential. Preferably choose the battery ka tails as zero. That will make your life easy. This is zero. If this is zero, zero. So this guy is V, this guy is 2V, this guy is 3V. This thing I don't know, let it be X. So let the charge be Q1, let the charge be Q2, let the charge be Q3. Preferably always take, going through the same thing. So it will be easy, sign convention में confusion नहीं होगा. Even if you take final minus initial, initial minus final, signs का problem नहीं आएगा. But if you take this is like this is like this, there's a chance you'll goof up a sign. I preferably take either all towards X or all away from X. That will make your life easy. So what is Q1? Capacitance C, potential final, initial minus final. So we are going from V to X. That's what you assume. So V minus X. Q2 is again 2C capacitance, 2V minus X. Q3 is 3C, 3V minus X is equal to 0. C goes off. V minus X, 4V minus 2X, 9V minus 3X. This is 14V. Numbers are not that great, but yeah. X is equal to 7V by 3. एक बार X का value आ गया, done, you'll get whatever you want. So Q1 is what? C into V minus X. That is minus 4CV by 3. Like expected, that is wrong. Matlab, Q1 is not coming out, it is actually going there. Like I said, the signs will take care of it. You don't worry about it. 2C, 2V minus X, 3 to 6. Again, this guy is also reverse. Minus 2CV by 3. This guy would be 9 to 6CV by 3. Meaning if you look at the final answer, this is the positive plate. 6CV by 3 is 2CV basically. Then the charge is going like this, and this is the positive plate, and this is the positive plate, which is 2CV and 4CV by 3. Clear? So 2CV is coming from here and it is splitting like this. That's the final charge distribution. Yeah, same thing. Heat transfer में भी use कर सकते हो junction law. But there we didn't do circuits that extensively. We are doing it here. All clear with this? Clear with the junction law? Take a break. After that, we'll see few more. Take a break. Come back with 7-7. Any doubt so far, you can ask me. Or let's take a break. Come back in 10 minutes. Turn the page. Previous one.
सर
हाँ रे.
सर जो जो हमारी जो रेजिस्टेंस जब निकालते हैं तो उसमें जो ई करंट का फॉर्मूला होता है वो यही होता है ना E1 R2 प्लस E2
That
R1
is
अपॉन
simply, that is only for 2 batteries.
हाँ ये सर तो लाइक अगर कैपेसिटेंस में होगा तो क्या लाइक हम बस वन लाइक R की जगह पे 1/C कर देंगे
हाँ,
अगर
you can do
कैपेसिटेंस
that, but I never tried it because it is useless here. So कर सकते हो, maybe. You
नहीं
can
सर
make a
बाई
formula
चांस
out of it.
हाँ सो लाइक अगर हम ई करंट निकालने एंड लाइक सी करंट निकालने तो उससे हम क्यू नेट मिल जाएगा और फिर हम डायरेक्ट रेशियो कैपेसिटेंस में उसको डाइवर्ट नहीं कर सकते डायरेक्ट
करो
रेशियो
करके भाई बोला अभी इतना काम करने से बेटर है कितना फास्ट हो गया 3 स्टेप में.
हाँ सर वो तो हुआ वो तो हुआ
वो तो है. You can figure it out, nothing wrong with that. करके देखो आ रहे तो अच्छा है. अभी देखो ना कंफ्यूजन आ गया ना. दिस इज नॉट द चार्ज ऑन ईच कैपेसिटर करके. अभी
हाँ
एग्जाम में
सर
हमको इतना टेंशन क्यों चाहिए? दैट्स व्हाट आई एम सेइंग.
ओके सर या सर
No, you can't
देयर
do
माइट
that
देयर
because
माइट
like,
बी 3-4 मेथड्स बट
but you can't do that, na, because it won't be in parallel like the capacitors. You can only you'll have to apply Kirchhoff's law, and then maybe if you get a relation like that, it may satisfy, but like it's
तो
not
वही बोल रहा
necessary.
हूँ प्रूव तो करो पहले प्रूव करो मुझे आई तो नेवर प्रूव्ड इट तो यू गाइस कैन प्रूव इट रेसिस्टर्स के लिए यू कैन डू स्टिल लेट्स सी Neil? Let's see. Neil? What happened here?
सर दैट लास्ट स्टेप में आपने जो रिमूव किया वो आप एक बार एक्सप्लेन कर सकते हैं?
Yeah, I was saying ये point और ये point same potential है ना?
हाँ
That you understood, right? Because the left and right are identical. So left में जो
Yes.
potential था right में भी वही होगा. So that means you can remove this capacitor in the middle, right? कि ये है ना
Yes.
center में this between C and C, this part is removed here. दिखा?
हाँ सर यस सर
Meaning if you don't remove this, na, you'll get stuck with the solving there. Then this will be one capacitor, this will be
हाँ
one
सर
capacitor. Actually, तो देखो ना Wheatstone bridge भी बन रहा है देखो. C by C is equal to this by this. It's a Wheatstone bridge.
यस
Clear? Next one, everyone. Find C equivalent. This is not Wheatstone bridge. I'll do one thing, Vital. Let me mess it up a bit. Let's make it 3C. Then I'll show you with C and 2C. That will make your life more easy. The previous one, still there's a symmetry. When I give C to C and 2C, there's a diagonal symmetry. First, let's try to do this. Then I'll show you that. This is better. If you know this, then the other one is quite easy. This is the reason, Aryan. C by 2C is not 2C by C. Balance नहीं हो रहा है. Same logic. Start with 0, name the nodes, potential, and then you're done. Try. I'll give 2-3 minutes and I'll show you. See. Let this be 0. This is 0. This is V. This is V. This is X. This is Y. Let this be Q1. Let this be Q2. Let this be Q3. Let this be Q4. Let this be Q5. Let this be Q6. You can take anything you want. That Q1, Q2, Q3 is simply for us to put the charges. Matlab, in this, you're getting charge Q1 plus Q4. So if I want to find C equivalent, I need to find the charge to the battery Q1 plus Q4 by V. Isn't it? Isn't that the charge coming out of the battery, Q1 plus Q4 then? So that was the main story. That so if you can find Q1 and Q4, my job's done. I'll get C equivalent. That is how the capacitance is defined, right? Let charge Q come out of the battery. Q by V is the capacitance. Now we are writing for the node X. So charge flow would be capacitance C into V minus X plus this side it will be capacitance 3C into 0 minus X. I'm taking Feynman's initial, and this guy would be capacitance C into Y minus X. This would be V minus X minus 3X plus Y minus X is equal to 0. This would be 5X minus Y is equal to V. This is equation 1. Node Y. This would be Q4 now. So 2C into V minus Y plus C X minus Y plus C 0 minus Y is equal to 0. You could have taken Y minus V, Y minus 0, Y minus X. Anything is fine. You're simply playing with the sign, nothing much there. So this would be 2V, 2Y plus X minus Y is 0. This guy would be 4Y minus X is equal to 2V. Two equations, two unknowns, substitute there. So take X from here and dump it there. You end up with 5 into X would be 4y minus 2v minus y is equal to v. This is 19y is equal to 11v. Shit, the numbers are really bad. Y is equal to 11v by 19. Got the same thing? Yeah. So if you got y, x भी आ जाएगा अभी. What is x? So x is 4y. So 44 by 19 minus 2. That is 38. So 6v by 19. आ गया ना? X and y आ गया. So what is q1 then? Remember this was q1. q1 plus q2 plus q3 was 0. This was q4 plus q5 plus q6 was 0. So from here you can find q1. q1 will be c into v minus x. So that is 1 minus 6 by 19. 19 minus 6, so 13. Yeah. 13 CV by 19. Q4 would be 2CV minus y. That is 19 minus 11. 8V by 19. And we have to add these two. 8 to 16. 16 plus 13. 20. 29. This is 29 CV by 19V. 29 C by. Yeah, looks right. You can take Q1, Q2. You can take Aditya any direction. See, what we are trying to write, Aditya, simply na, the charge in this node is 0, na. Either you take away or you're taking towards, it doesn't matter. But if you say you want to take like this, plus itna dhyan rakhna, then in this case the charge flow would be Q1 plus Q4 inside. So you'll get a minus sign. Right? 19 minus 11, 7, yeah, happens. Is this clear, everyone? Even though it looks quite complex, in reality, you're just solving two equations. Numbers are bad. The same thing if you try to use Kirchhoff's loop law, it goes quite long. Nodal analysis saves you time. Is this clear? But this is a circuit, you can't do anything. No series, no symmetry, nothing. There's no other way. This is not a Wheatstone bridge. You can see how complex it became. Let me take a simpler version of this. Same question. This would be a easy version of this. Like I said, in this, there's a symmetry also. C, 2C, 2C, C, and C. Now find C equivalent. Now here, what is the symmetry here? Let me show you. Same thing, you'll start with 0, 0. This is V, V. Now this is the symmetry here. If you take this as X, now you can clearly see here, this branch here and this branch here, they're identical. Whatever happens here on the top, the same thing happens on the left side here. So we call this thing diagonal symmetry. Crisscross, they're looking identical. That means if this potential difference is V minus X, this potential difference also should be V minus X. So we can write this point as V minus X. You're getting it? Everything, whatever happens here, the same thing will happen here. Whatever happens here, same thing will happen here. There's a symmetry there. This is a diagonal symmetry. Diagonally, they look identical. So we can say potential difference is same. You can't say potentials are same. Getting it? So it is really not a great thing, but when in Kirchhoff's law, it will help you to reduce one more equation. Is this making sense? This is a diagonal symmetry. So if I just put it in more details, this is the idea that C1, C2, C2, C1, C3, this is what you can say. If you say charge Q is flowing here, you can say Q is coming out here. If you say this is small q, you can be sure this is small q. Then if you say this is Q minus Q, you can say this is Q minus Q. So these two sides and these two sides will look identical. So from that thing, you can argue if this point is A and this point is C, if this point is D and this point is B, You can say VA minus VC will be same as VD minus VB. इससे कुछ simplify directly नहीं होगा. You just reduced one node. Instead of having two variables, you have only one variable now. And then you know the story here. Let this be Q1, Q2, and Q3. So when you solve this, you'll directly get C into V minus X plus C into V minus X plus 2C into 0 minus X. This would be V minus X plus V minus 2X minus 2X. You get X is equal to 2V by 5. Basically, directly you'll get X ka value. You just eliminated this Y ka node. VA minus VC is VD minus VB. Yeah. Is this clear? So if you have 2CC and C2C, this is still, it will make your life easy. You have to write only one node ka equation. If you have everything weird, then you have to write two nodes. That's why I said this. If you know this, you can handle. Sometimes exam you click nahi hoga, then fine, take X and Y and just solve. Like I said, this is really not a super symmetry or something. It really doesn't much of a sense. Clear? There. So that is how you can use this nodal analysis, this junction law. Now let's say the Kirchhoff's law. This I'll just show you one or two circuits how to do. But especially we'll use this in, we can use this here also. I'll show you we'll use it here. So what is Kirchhoff's loop law? So Kirchhoff's loop law is simply another form of law of conservation of energy. This was CET questions, huh? What is Kirchhoff's junction law? Is what? Conservation of charge, conservation of energy, conservation of momentum, conservation of angular momentum. What is the Kirchhoff's loop law? Conservation of charge, conservation of energy. CET questions ऐसे ही होते हैं, gods. You have 50 physics questions, 50 chemistry, and 50 maths, 150 questions. So CET questions, some of them are like that. Are they?
3 hours.
3 hours. And max ka +20 hai.
Wow.
Max is 100 marks. Physics is 1 mark each and chemistry 1 mark each. That is the reason CET people get slotted in mains. They think there is a lot of the questions and mains mein to they get slotted. Now what is Kirchhoff's loop law? This thing says the sum of potential differences across the elements in a closed loop is 0. Kind of makes sense. Think about it. You start from one point and you come back to the same point. The potential difference is 0. But a better way of writing this is the potential difference between 2 points is sum of potential difference across the elements in any path between the 2 points. Means if you're going from A to B, you take any path, the sum of all the potentials in the middle will give you the potential difference between the 2 points. Meaning what it is saying, let's say if you have a circuit like this, I'm just giving an example. You start from here, you want to go here. What it says is you go like this, the potential difference is VA minus VB. You go like this, the potential is VA minus VB. It doesn't matter. So basically potential is just like a state function. It doesn't depend on the path. Now in this, we need to know the sign convention. I'll show you how to do this. This has its own advantage. This is especially useful when you're dealing with a combination of capacitor, resistor, and all these things. You mix it up, right? This will be quite useful. So sign convention, this is what we do. When we go from higher to lower potential drops. So first thing, if you take a battery, we know this is minus, this is plus. So in a battery, if you go from left to right, you're going from negative to potential terminal. So you have to write plus V. If you go from plus to minus, the potential drops, it is minus V. So when you're going through the loop, if you pass through the battery from negative to positive, the potential rises. And if you go from positive to negative, potential drops. If you take a capacitor, and let's say if this is plus Q and this is minus Q, if you go from positive to negative plate, potential drops minus Q by C. If you go from negative to positive potential increases plus Q by C. This is a sign convention. Let's see an example how to work this. Now, if you want to solve circuits, I would prefer junction law, but we will know both the techniques. So if you want to solve a circuit with this, these are the steps. First thing, if there's more than one battery, assume charge Q coming out of any one battery. It doesn't matter. You assume science will take care of it. Second, then using junction law, distribute the charges at the nodes. Third, apply Kirchhoff's loop law. Such that all elements are covered at least once. This is one thing you have to be careful. You just cannot leave any one element. That you should make sure every element is covered in that loop at least once. And solve the equations. I'll show an example that would be better. And you want to find C equivalent, assume a battery V and find Q by V ratio. So if they just give you the circuit and ask you find C equivalent, put a battery V giving charge Q, and find Q by V. So let me show you an example. So let's take this guy only, which we did. This one. Let's take this example only. All right. On the side. So this guy is V, this guy is C, C, 2C, and 2V. Okay. Step 1. Assume charge Q from any one battery. I'll assume from this guy. So as the charge is flowing, remember, whichever the charge touches, that's your positive plate. Now, how do you know that's the positive plate? I don't know. Assume. Science, assume Garlo, science will take care of it. I'm not drawing the negative plates. So charge Q is flowing like this. Then the charge will split here. Let's say this guy became Q minus Q. The remaining charge will go here. This guy became Q. So Q came out from here. Q minus Q came out from here. And Q back. Got the charge distribution. Start from anyone, distribute the charges, small q, capital Q, and finish it off. Next thing, assume a loop. I will assume this is one loop, and I'll assume this is one loop. You have to go in a loop. So I'll start from here. I'm starting from here. So I'm going this way. So look at the right loop. Listen carefully to the convention. I'm starting from here. So I'm going through the battery, negative to positive, so plus 2V. Then I'm going from positive to negative plate of a capacitor. The potential will drop, minus Q by 2C. Potential across the capacitor is Q by capacitance. Then I'm going down here. Again, I'm going from positive to negative plate, minus Q by C equal to 0. So this guy would be 2CB is equal to Q by 2 plus Q. Now, if you take the left loop, again, I can start from anywhere. I'll start from this way. I'm going opposite to the terminals. So that will be plus Q by C. See, here I'm going from negative plate to positive plate. The potential rises. Then I'm going again minus Q by C. Then I'm going opposite to the battery minus V, and I came back to the same point. This guy would be Q minus Q. 2Q minus capital Q is equal to CV. Two equations, two unknowns. Bring that Q here and finish it off. So this would be 2CV minus Q by 2 minus Q is CV. This is 4CV. This would be 3CV is 2Q. Q is equal to 3CV by 2. And small q would be 3CV by 4 minus this 5CV by 4. So did we get the same answer here? Yeah, we got the same answer here. 3CV by 2 and 5CV by 4. There's a high chance you'll goof up something in this. You'll put one minus n wrong there. You'll do something here, there. But look at the steps. Left loop I started here and then I went like this. You start anywhere, no? Doesn't matter. Same आएगा. अगर तू यहाँ से start करोगे ना, then this will be the first term. This will be the second term. ये third term आएगा. Doesn't matter where you start from. You could have taken loop like this also if you wanted. Doesn't matter. Please have a look at this. Let me give you like this one more. You guys just write the equations. No need to simplify. Steps wala page here. So this problem now, this we can solve, but you will die. Okay. That'll be very bad. You get so many equations. So just we'll write the equation so that you guys will understand how to write the equations. Now, for convenience, right, what will I do? I'll do the distribution. Step 1, assume charge Q coming from here. So this would be Q. This would be Q1. This would be Q minus Q1. This will be Q2. Then this will be Q minus Q1 minus Q2. So this would be the positive plate. This is the positive plate. This is the positive plate. And this guy would be Q1 plus Q2. This is the positive plate. And this is the positive plate. And finally, Q comes out. So we will write this is one loop, the left loop. We will write this is one loop. And we will write this loop. So we need to get 3 equations, 3 variables. Left loop, the right loop. And starting from here, we're going like this, up say. Understood how we went? Or you want to do adventure, you can go like this, you can come down, then you can go like this. Doesn't matter, everything works. So let's write the 3 equations and I'll show you the answers. Let's see if you got the same equations, you can solve it. So this is a loop, you're going in this loop, and then you're going in the upper side and coming down, 3 loops. Just write the equations. I just want you to get the sign convention right. Solving part is fine, you'll get 3 equations. Solving, it's a mess. The difference between this and nodal analysis, now you got 3 equations here. Nodal analysis, you solved it only with 2 equations. The reason you assumed one node is 0, na, that made your life easy. You reduced one variable. Kirchhoff's loop law ka ye problem, you'll get one extra equation. And there's a high chance you'll goof up one sign somewhere. Sign convention mein plus minus one thing goes off, the whole equation goes toss. Just write the equations. Left loop, right loop, and then that big loop. Give it a try. I'll give you a minute. Write the equations. I'll show, then you can verify whether you wrote the right thing. Then it is just a matter of solving. Answer aa jayega. Should I show you? Look at the left equation. You can start from anywhere. I'll start from here. End of the term should come same. So minus Q1 by C plus Q2 by C plus Q minus Q1 by 2C. Please ask if you didn't get that. Because when you go from here, look at this. You're going from the positive to negative plate. So there's a potential drop. Here you're going from negative to positive plate. So if you're going with the charge, potential drops. If you go opposite to the charge, potential increases. You can remember like that. Obviously, charge always flows from high to lower potential. So if you're going with the charge, potential drops. If you go opposite to the charge, it means you're going against the river. So potential should rise. The right loop, I'm writing from here. You can start from anywhere. Minus Q1 plus Q2 by 3C because you are dropping there. Then I'm going again opposite to the flow there. So Q minus Q1 minus Q2 by C. And again, I'm going with the flow. So minus Q2 by C is equal to 0. and that big loop, I'm starting from battery here. So I'm going to the battery V minus Q1 by C minus Q1 plus Q2 by 3C, and I came back. 3 equations, 3 unknowns, solve, you'll get the answers. Brute force. There's no other way. You have to solve. But check your equations. Anyone didn't mess up the sign anywhere confused, please ask. Is this clear? All got this? Now let's see how this is actually useful in certain type of questions. Let me show you one. So normally if someone asks you like this thing, now use junctional, it is safer. There is a less chances of doing mistakes. Because यहाँ पे कैसा है ना, you just need to mess up one sign here and then that is sufficient. The whole thing will go for a toss. Then again, this has its own advantages, like this one. This is a baby maze. So we have a battery, all capacitances are there. Find charge on capacitancy. The one which is a symbol. This C ka value is all our capacitance C, which is equal to 2 microfarad. But specifically, I'm showing you this one you have to find. How to do this? नहीं, कुछ भी नहीं है actually. This thing, you'll see a more deadly one. We will see that in current. I'll just show you how it looks. That's how it looks. We will see that in current. For now, let's do this thing. Kirchhoff's loop law is the useful thing. I'll tell you the idea. See, the idea here is, problem kya hai na? Find a path where you are going through the batteries and you're going only through this capacitor. See, problem kya Kirchhoff's loop law ka? If I go like this, then I have to find Q by this charge also, na? So avoid all the capacitors. Find a path in this circuit such that you're going only through the batteries and only through this capacitor. Bus. It's like it's a maze. So if you can do that, then it doesn't matter what the charge on the other capacitors. So you need to find a path such that you're only passing through this capacitor and any battery there. The people who are good at the Times of India ka solving magazine ke piche, you will be experts now. Finally, you had a purpose of solving all those things. Found it? So start from here. ये easy था फिर भी. So let this be charge Q. आ गया? So if you apply Kirchhoff's loop law in this loop, you will observe 20 minus Q by C is equal to 0. So Q is equal to 20C, 40 microcoulombs. Easy? So that is the main thing here. Someone gives you a circuit like this exam, they're not expecting you will simplify. Anyway, we just did this thing, तो इसका भी निकाल देते हैं अभी. Can you just find इसका path? Just find the path. We will solve this later on. I want you to find the current in this junction, and I want to find current in this junction. Means you need to find a path such that you should go through all batteries and only this resistor. This resistor is fine. This whole thing is anyway in series, so problem nahi hai. Just find the path. You just need to find a path for this resistor. Just find the path. I'll give you a minute. This again we will solve in current electricity. But for now, let's use your maze solving skills. Let's put it to test. You should pass only through this resistor and all should be batteries. You should pass through only this branch and all should be batteries. हाँ, batteries include करना ना God. Batteries are fine. Because see na, when you go through a battery, the charge won't matter, right? When you go through a battery, charge या current matter नहीं करेगा. Problem कब आएगा? If you're going through a capacitor, then the potential is Q by C. Then I should know the potential charge on that capacitor, isn't it? Which is variable. Did you find the path? See, for this guy, this entire thing is same branch, so that is fine. I'll go like this. आ गया ना? And for the green guy, I can take the same path again. मिला?
Sir, I think you can just go बाहर से वो right
ये
से
से भी
चालू
जा
कर.
सकता था. हाँ, वो भी कर सकते हो. Green के लिए there are multiple paths. You'll find multiple paths. So like that you can find for anything there. Sometimes you can't find the path, so you can't do. So like this. So these are infinite. These are big grids. Maze. These are called maze circuits. So when you see something big like that, means you have to find a path. So don't get tensed and thinking like, how the hell will I simplify this? So anyways, I will see. So in this thing, right, Kirchhoff's loop law is quite useful. Okay. So that is some of the circuits there. So next class when we catch up, we'll continue from here. We will do what happens if there's no battery, if you're connecting capacitor to capacitor, capacitor charging, discharging, and all that stuff. And then we will see dielectric slabs. So mostly we should wrap up in next class and maybe another 1.5 class. So next Friday, we'll finish all the chapter and we'll start off with current electricity next Friday. At least we'll start off with the introduction. So we did the main part. Like I said, whatever I taught you in circuits, exact same concepts we'll use in current. So as far as the concepts part is concerned, it is the same thing for circuits. But current is quite big. Current has many other variations also. Okay, so with that, we'll wrap up for the day. So any doubts in today's class? Anything else you can stay back and ask, or else you're free to leave. I'll see you on Wednesday. So take care, stay safe.